Okay, pretty soon you're going to see an image of the solar system. It's not drawn to scale or very well at all. Here we go. Alright, let's zoom in here. We're going to tell you why this interstellar comet thing is so amazing. Start right here. This is the sun. It is a giant ball of plasma and gases that are responsible for everything in our solar system. It's amazing. First planet is Mercury, tiny little chunk of rock that's really hot, but it's not the hottest. That goes to Venus as the hottest planet. And why? Because of the greenhouse effect. Climate change is real, kids. Next we have Earth, that's our home. Next we have Mars, that's our next home. Then we have the asteroid belt. The biggest difference between asteroids and comets, although there are many, but this is the easiest one to remember, is that asteroids are rocks with metals in them, and comets are big chunks of ice with some rock in them. That's why they glow. They get close to the sun and they start evaporating and giving off little chunks of their body, and that's what we see. Okay, after the asteroid belt, we have Jupiter. Jupiter is the largest mass in the solar system that's not the sun. The reason the asteroid belt doesn't kill every living thing on Earth every 15 seconds is because of these planets here, mostly Jupiter. After Jupiter, you have Saturn with its famous rings. Then you have Uranus, giggity. Then you have Neptune. Those are the only planets. Sorry, Pluto, we'll get to you. After Uranus and Neptune, you have the Kuiper Belt. This is a big ring of ice and other small debris. Most of the what we call short-term comets come from here, or the scattered disk, which is another field of debris that reaches way out into the solar system, but it's still trans-Newtonian. Neptunian. Sorry. So, most of the comets we know and love come from here. This has got a question mark. There is a theoretical planet called Planet 9. Sorry, Pluto, you're still not a planet. If this planet exists, it'll be really huge compared to Earth. It'll be rocky, and when I say rocky, I mean icy with some rock in it. And it will account for some of the gravitational wobbling that we don't currently know exactly why it occurs today. We don't know that it's there. It's called Planet 9. It won't have a real name until we do. Now, you know and love Pluto. Pluto's not a planet. Pluto is just a really, 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 really big object in the Kuiper Belt. It has a moon called Charon. We used to think Pluto was a planet and that Charon was its moon. Then for a while we thought Pluto might be a moon of Neptune actually, and it just had a really weird orbit. But we now believe Pluto is a big chunk of the Kuiper Belt, and that Charon might not be its moon, but might be part of a binary planetoid system. There are other tiny little mini planets out there, but we won't go into it because it doesn't matter. Now, way the hell out here, and there's this big field between the Kuiper Belt and the Oort cloud. It's not important. But way the hell out here is the Oort cloud. This is just trillions upon trillions upon trillions of little chunks of debris and ice. And we don't even know if it really exists. We only know that most of the long-term comets come from here. We theorize that this Oort cloud exists because it's the only way we found mathematically to make some of these trajectories make sense. We know they stay within the solar system, but we also know that some of those orbits are millions of years long. So, Oort cloud, Kuiper Belt, scattered disk. That's where most of our comets, I say most, all of our comets come from. Now, I told you a minute ago that the short-term comets come from the Kuiper Belt and the long-term comets come from the Oort cloud. That's not 100% true. Some of the so-called Halley family comets came from the Oort cloud, we believe, had these really long, thousands or millions of years orbits, And then one of their orbits probably took them somewhere near some of the outer rim planets, got caught up in the gravitational field, probably of Jupiter, and it swung them back. And then they got closer to the sun, and then they got a more stabilized orbit. That's why we see Halley's Comet every, 76 years? So it started out here, went in there. Now, what's so cool about this particular comet that has made this video possible is that this is the border. It's the absolute cosmological limit, we believe, of our solar system. And if this comet came from outside the solar system, probably in the Lyra constellation, that means we are seeing interstellar matter that's going to come in, swing by Sol, and shoot right to hell back out. It's the first time we've ever known that to happen. It's probably happened before, but we've never been able to observe it. We may never be able to observe it again. Who knows? It's a big galaxy. This is an amazing scientific discovery. We don't even know if it's real yet. We're just assuming it because of what the trajectory looks like. A lot of studies got to happen, and a lot of observations got to go on, but this is a big deal. Okay, there's your nerd stuff.